It's a great pleasure to introduce this morning Danae Hernandez Cortes, who is joining us from the University of California at Santa Barbara, where she is finishing up her PhD in energy economics and environmental economics, and where she is a student of energy and environmental justice. And we are, excuse me, just a second, not quite sure why I got confused here. Anyways, we are super excited to have her join us this morning to give her talk. And so Danae, I'm gonna turn the floor over to you and welcome you to share your screen with us, and we will look forward to hearing about the work that you have been doing in Mexico and in California on the equity implications of environmental policy. So Danae, the screen is yours.
Great, thank you so much. Sorry, thank you so much for having me. I'm really excited to be here and to present my research. And it has been a lovely day meeting people and getting to know your schools. And I'm really looking forward to my meetings today. So thank you so much for all of your insights and all of your questions. I have learned a lot. Well, my name is Danae Hernandez Cortes, and I am going to be presenting the equity implications of environmental policy. And I will start introducing something that must not be a surprise for you. We are ongoing a worldwide energy transition. As we know, the share of renewables has increased exponentially in the last few decades, and it's expected to keep increasing as more countries try to reach a goal of decarbonization of some of their sectors. As such, energy transitions are happening around the world and will keep happening in the future. Many economies around the world have plans for decarbonizations in the future. Even some states within the US and some countries throughout the world have pledged some paths for decarbonization of their fleet and some other programs to try to increase the renewable energy production and at the same time try to regulate conventional fuels. However, it is unclear how decarbonization will occur and how this energy transition will look like in the future. And different paths for decarbonization can have very different distributional outcomes depending on the policies and the paths taken. And what do I mean by distributional outcomes? What I mean is that some of these paths could lead to more environmental inequality than others, or could lead to more energy poverty than others. And this is very, very important because there is an environmental justice concern regarding energy transitions. And what is the environmental justice concern is that populations that have minorities or low-income communities can be exposed to a higher share of environmental phenomenon. So as we see here, polluted places tend to be in poorer areas and have more minority populations than other less disadvantaged places. So here we see the poverty levels in California and their pollution exposure. And we see that there is a positive correlation between people that are experiencing poverty and the amount of pollution they are exposed to. The same way, minority communities are experiencing a higher level of pollution exposure. So here we see people that are either African-American or white, and we see that people that are African-American have a higher pollution share than whites around the US. So these different environmental justice concerns could make it hard in order to try to achieve a decarbonization that looks equitable in the future. So now my research agenda focuses on answering how to design environmental policies such that we can achieve equitable energy transitions. And in specific, I seek to inform how energy transitions can increase environmental equality for disadvantaged communities. And I do so through the lens of empirical economics, which means using methods from causal inference together with tools from other disciplines. And I try to understand the following: whether some policies can achieve energy transitions while at the same time reduce existing environmental disparities. Now, throughout my research agenda, there are two main questions that I am trying to answer. The first one is whether environmental policies affect environmental inequities, and whether what are some of the challenges for energy transitions that we need to be aware of in order to achieve an equitable energy transition. And in terms of the methods that I use, all my research uses causal inference methods, but it also uses tools from other disciplines and also from other, and I use a lot of data in order to answer these questions. Within the methods that I use administrative data as well as satellite data, geographic information systems, as well as physical science methods in order to try to answer some of the questions that I am interested in answering. In terms of the outline of my talk, I will be explaining some of my current research projects and my research pipeline within these projects, as well as some of my research, my research agenda for the future within the same topics. I will also explain the policy relevance of my research and the stakeholder engagement, and as well as my teaching interests and my paths for advancing diversity. Please, throughout this talk, if you have any questions, feel free to interrupt me in order to have some clarifying questions or so. I am very happy to answer those. So now let's begin with telling you a little bit about the key takeaways of my research. Throughout my research topics, you will learn 4 key takeaways that I have concluded from my research. The first one is that the design of energy policies is important for achieving an equitable energy transition. The same way, in my research, I have found that environmental policy can have unintended consequences, especially for disadvantaged communities. Also, that climate policies can help reduce environmental inequality. And finally, that the infrastructure for energy transitions might benefit income groups differently. And we need to be aware of these differences in order to be able to create infrastructure that will benefit everyone in the income distribution. Now, the first paper that I'm going to be talking to you about is the distributional consequences of incomplete regulation. In this topic, I am going to be covering the first question that I am interested in answering in my research agenda, which is, can energy policies affect environmental inequalities? And the types of methods that I use is causal inference methods, as well as administrative data, satellite data, and geographic information systems. Energy transitions will likely involve some sort of policy interventions. These policy interventions can sometimes be incomplete. What does it mean for a regulation to be incomplete? Well, that it does not cover all sources of pollution. So you can imagine that there is one regulation that is trying to tackle gasoline, but is not tackling diesel. That could be an incomplete regulation because since both are polluting, some people that are using gasoline can go to diesel and vice versa. So that is what we mean by incomplete regulation. These incomplete regulations are very common throughout the economy. Sometimes some counties are regulated by some policy act. Sometimes other counties are not, or some sectors have an energy standards and some sectors do not have them. And why are some of the reasons behind this incomplete regulation? Well, there could be several reasons, but among the most common are either monitoring costs, because it's very hard to monitor some sector and not another one. There could be political incentives. Sometimes it's you want to benefit one group besides another on top of other one. So there could be many reasons why these incomplete regulations take place. However, incomplete regulations can have unintended consequences and affect the most vulnerable communities. In this research project, I am going to try to answer whether firms reallocate pollution when there is incomplete regulations, and what are the distributional consequences of incomplete regulation in when there is one of these regulations. And in particular, I am going to explore it in the case of Mexico in the fuel-specific policy that was targeting all the industrial facilities in Mexico that were not using biofuels as main source of fuel. And I'm going to use the sugar production industry in Mexico as a case study, because it is very interesting how this substitution can occur within this industry. And because sugar producers in Mexico, some of them use biofuels and some of them use other conventional fuels, such as natural gas or oil as a main fuel. In regard of the related literature, many other studies have found that whenever you have an incomplete regulation, the pollution that is coming from the unregulated sector can increase as a response of the regulation. So I am going to try to study this and see what is happening in the case of the sugarcane sector. Now, let me talk to you a little bit more about the setting. Mexico is the 6th largest sugarcane producer and employs nearly 2 million people in the whole country. There are 2 main processes throughout the sugarcane production. The first one is harvest, and the second one is processing. Harvest occurs in a field where sugarcane is growing. And in order to cut this sugarcane, you can either use manual cut or mechanical cut. If you're using manual cut requires field burning in order to make it easier for manual workers to cut the sugarcane that is being harvested. And when that happens, the whole field is burning like this. And so you are able to cut sugarcane faster and allows it for an easier harvest and cleaning the sugarcane, which is very important. Whenever this is occurring, 96% of the particulate matter that is emitted is respirable, affecting surrounding communities and can affect health outcomes of kids nearby and also adults. The second process is processing, and this means taking sugarcane to process it to sugar. The final product is sugar, and these facilities are also heavily polluting. So for example, they emit 2,500 tons per year of NOx. And just to put it in comparison, the average California cement producer emits half as much as this. So this is a very heavily polluting firm too. And the types of fuel that they use is either, again, oil or biofuel. And we have a very good mix of about 60% using oil and the rest using biofuels as main source of fuel. But also another important characteristic of this setting is that the places that are exposed to the burning that I was showing you are also poorer. So here you can see the distribution of poverty rates between the places that are exposed to sugar mills in the blue and the distribution of the poverty rates of the municipalities exposed to sugarcane burning. And there is about 10% difference in poverty rate between both of them. So the places that are exposed to sugarcane burning are on average poorer than the places exposed to sugar mills. And now let me give you a little bit more of background about what I am doing in this project and how did the regulation work. Imagine that you are a sugarcane producer. And so you have 2 alternatives to cut your sugarcane. The first one is using fires and manual work in the field. Since you are using fires, you are going to produce particulate matter or other pollution while burning your fields. Alternatively, you can use an agricultural cutter that does not pollute in its majority. When you finish cutting this sugarcane, if you use fires, you also clean the sugarcane, so the sugarcane doesn't have to go through an additional processing in the mill. So then it arrives to the mill and then it produces sugar. However, if you're using an agricultural cutter, the sugarcane is dirty because it has excess vegetation that needs to go through an additional process in the mill that will lead to more pollution. At the end, you have sugar, and there is no difference in the quality of sugar between agricultural cutter or manual cutter. And finally, the sugar goes to the market so we can consume it. However, as I told you, if you are using fires and manual work, it needs less processing than if you are using an agricultural cutter. And in terms of this regulation, this part of the production was regulated and this part was not regulated. So if we are seeing that sugarcane growers are substituting the type of inputs that are using, we will see them going from this branch to this branch as a response of the regulation. So that is what I am going to examine throughout this paper. Here is the extent of where sugarcane is being grown in Mexico. So the circles are exempt facilities, therefore facilities that are using biofuels, and the triangles are non-exempt facilities that are using conventional fuels. The gray area is just the extent of fields that are in Mexico. So it's a big crop. Sugarcane it's very extensive. So now, how am I going to try to answer this question? So first, I am going to collect and analyze data from several satellites and several remote sensing tools in order to try to know the pollution and the fires existing in these areas. So I'm going to collect data from NASA and the VIRS product, as well as MIRA-2, which is another satellite that allows me to get information of pollution from these production activities. The step 2 is to link this data for satellites that is used with satellites to administrative data. And I got data on production and outputs of all of the sugar mills in Mexico. And I also got data on their weekly production and use of inputs. I associated as well to the extent of their use of fuels, so which fuels they were using, in order to see who was regulated and who was not regulated after the policy started in 2014. And the step 3 is to try to estimate the effects of the policy. And how am I going to do that? I am going to compare exempt facilities and non-exempt facilities before and after the policy took place. And with this in mind, I am going to see whether these facilities change their behavior as a response of the regulation that was trying to regulate polluting facilities. So what do I find in this research? Remember, this policy tried to target the mill because it was heavily polluting. Since the mills can substitute towards fires in the process that was being regulated, if they were actually substituting, we should see an increase on fires. And as such, I find that after the policy started, I see an increase on the number of harvesting fires as a result of the regulation. Consistent with the increase on fires, we should see an increase in pollution associated with such fires. And in fact, I see that the pollution increased as a result of the policy. And there was about a 6% increase in pollution coming from these fires. Now, what happened to the mills? Remember, this regulation tried to target these mills because they were heavily polluting. So we should expect seeing a decrease in the pollution exposure near these mills. And yes, I find that there was a decrease in the pollution near the mills of about 3% after the policy took place. So this policy did indeed make pollution facilities less polluting. However, it did increase pollution in another non-regulated production process. Now, consistent with the increase on fires, we should see that the inputs related to the use of manual work should increase. And as such, I see that the manual cut increased as a result of the policy, as well as the number of agricultural workers used during this production process. Finally, I do not see any change in total sugar produced. However, it's a little bit of a noisy measure. So I don't see any change on the efficiency of these facilities. I only see this substitution towards a more dirty input. Now, what was the effect of this? We see that the fires are located in rural areas, as I told you before. So what was the effect in terms of the people who were exposed to this regulation? I see that comparing disadvantaged communities to other communities, I see that the communities with the highest level of marginalization, this means that the communities that are poorer on average experience a higher increase on the regulation coming from fires. I do not find any difference in pollution exposure between disadvantaged communities for the pollution on meals. However, I do find that the increase in fires was associated with the poorest communities being exposed to the highest pollution after the policy started. So in summary, this paper shows us that energy transition policies can have unintended consequences if we are not aware of the potential substitution that the facilities that are being regulated may have. It is important, therefore, to understand pollution sources and their responses to regulation. And also, we can also see that incomplete regulation can cause other environmental problems, particularly in places that have a higher share of disadvantaged communities. In terms of the takeaways that I was telling you at the beginning of the talk, what we learned from this talk is that the design of energy policies is important for achieving an equitable energy transitions, and environmental policies that can have unintended consequences for disadvantaged areas, particularly when we are not aware of the possible responses to these energy transitions policies. In terms of the next steps within this project, I am planning to analyze what are the health impacts of pollution exposure due to burning in these areas. And I am going to use a similar setting, given that I have data on all hospital information for kids in Mexico for all of these years. Also, I am planning to understand whether clean harvest technologies can lower the overall pollution exposure and reduce pollution inequalities in the US. And I am currently trying to study this for sugarcane pollution as well, and near an African-American community in Florida that has also said that the pollution coming from sugarcane burning is heavily affecting communities of color. So next, I am going to explain you my second project, which is trying to see whether environmental markets can cause environmental injustice. So now, this project is together with Kyle Meng at UCSB. And this project is contributing again to the first part of my research agenda, which is whether energy policies can affect environmental inequities. And I am going to be using causal inference methods together with GIS and physical science methods in order to answer this question. Market-based policies regulate around 22% of global greenhouse gas emissions, and this figure is expected to increase as the Paris Climate Accord takes place. So here you see a map of all of the countries that have implemented some sort of environmental market in order to regulate greenhouse gas emissions. And what do I mean by an environmental market? I mean one carbon tax or an emissions trading system in order to decrease greenhouse gas emissions. So it is a great part of all of the greenhouse gas emissions globally. The key feature of these policies is that market forces determine where pollution is occurring. And by doing so, it lowers the overall cost of meeting an environmental objective. However, there could be a spatial reallocation of pollution that could lead to relatively greater pollution exposure for disadvantaged communities. Therefore, this is a central tension because the same market forces that enable low cost for achieving an environmental outcome can increase inequality in pollution exposure, especially for cap and trade policies. So how does a cap and trade works? First, it sets a cap on the overall level of emissions, and then it allows firms to trade pollution permits in order to pollute. However, the concern is that the most polluting facilities might be accumulating these permits such that they can use them and pollute more near disadvantaged communities, which is very relevant to existing environmental disparities, particularly in California, since most disadvantaged areas are exposed to higher levels of pollution exposure. There have been a lot of environmental justice concerns over market-based policies. For example, the renewal of the European Union emissions trading system in 2013, as well as the Washington State carbon tax in 2016, and the Oregon State climate policy in 2019. In the case that I am going to be studying is California, which climate policy also had environmental justice concerns since its inception in 2011 till 2017 during its renewal. So the question that we're trying to answer in this paper is whether the pollution exposure gap between disadvantaged communities and other communities changed following the introduction of the greenhouse gas cap and trade program. And how does this work? In case of greenhouse gas policy, greenhouse gases do not have a direct health consequence directly. However, when they are produced, other pollutants are being produced that could be affecting the health of the nearby communities. So therefore, the environmental justice gaps depends on the local on the production between the local pollutants and also greenhouse gases. But also the markets that the market-based policies can induce more a higher reduction on pollution exposure, on pollution emissions from places that are dirtier. Therefore, if we see a change on this pollution, should be coming from the places that are the dirtiest places. There have been, of course, many other studies that have tried to analyze what are the consequences in terms of environmental justice for other environmental markets in the world. To put an example of some people in ASU as well, Sheriff has done some work on that. So now the setting that I am going to be studying is California's greenhouse gas cap and trade program that started with the name of AB 32 and established the world's second largest greenhouse gas cap and trade program in the world, and it started in 2013. The environmental justice concern for some communities is that the greenhouse gas cap and trade could widen the environmental justice gap between disadvantaged communities and other communities. And this discussion has been happening since 2011 and 2017. Now, answering this question causally can be challenging. And the first challenge is that we have to estimate the change in emissions, and we have to do so trying to solve a problem that is like these regulated facilities were also regulated, but by some other policies that could be affecting the level of emissions, but also there were some economic trends throughout the program that could have changed how these emissions were occurring. To do so, we are going to exploit facility level eligibility criteria and the timing of the greenhouse gas cap and trade program in order to examine what are the emissions coming uniquely from the program. The challenge number 2 is that we have to model pollution exposure, and there have been several methods to do so. For example, you can assume that pollution can stay within the same place that is being emitted, or that it follows a uniform circle surrounding the facility, and so forth. What we did was to use an atmospheric transport model that models pollution exposure using atmospheric patterns in order to associate pollution emissions to pollution exposure. So here you see that the little dots are all of the facilities that were regulated under cap and trade, and the lines are the trajectories using weather patterns for all of the this is for 1 month of our study, but we did this for all of the years during the cap and trade program. So how do we do it? First, we are going to isolate the cap and trade driven emissions by comparing regulated facilities versus unregulated facilities before and after the program started. Then we are going to predict the emissions coming uniquely from the program, and we are going to use this atmospheric transport model in order to model the transport of emissions to exposure, and then obtain the exposure of all of the communities in California. Finally, we are going to estimate the change in the environmental justice gap, which means comparing the difference in exposure between disadvantaged communities before and after the policy started. So what do we find? We find that before the program started, we see an increase in the environmental justice gap. meaning that there was an increase in the pollution exposure difference between disadvantaged communities and other communities, which implies that environmental justice was decreasing. In other words, there was an increase in inequality in pollution exposure before the program started. However, we see that after the program started, we see a complete reversal of that trend, meaning that disadvantaged communities experience a higher reduction in pollution exposure from the program than other communities. We estimate this not only for PM 2.5, but also for other pollutants such as PM10, NOx, and SOx, finding that for all of the pollutants that we examined, there was a decrease in environmental injustice after the policy started, coming only from pollution exposure. So in these terms, we find that California's greenhouse gas cap and trade program generated environmental justice co-benefits after the implementation of the program. And it reverses a previously widening environmental justice gap for all of the pollutants that we examined. We examined that by 2017, the environmental justice gap reduced to 2008 levels. However, there are some caveats in this study. For example, the environmental justice gap is still there. We only saw a decrease to the 2008 levels. And more importantly, not all market policies might bring environmental justice co-benefits. And it's important to do studies that consider all of the potential location of polluting facilities and with respect to other communities in order to try to see whether these communities might benefit or not from cap and trade and other environmental market policies. In terms of the key takeaways that we have, again, the design of energy policies is important for achieving an equitable energy transition, but more importantly, climate policies can help reduce environmental inequality depending on the place where they are imposed. In terms of the next steps, I am currently done evaluating some part of other market-based policies and its distributional consequences, in specific, the Mexican emissions trading system. We did one book chapter in order to try to analyze this, and is currently under revision. I am also trying to examine other possible sources of environmental justice concerns due to the energy transitions. In particular, I am interested in exploring this, whether renewable energy projects can alleviate poverty in some parts of rural Mexico. Finally, we're also trying to examine under what general conditions market-based policies can affect disadvantaged communities in other settings. And this is joint work with other people at UCSB. In terms of policy engagement within this project, together with my lab at UC Santa Barbara, we have worked in the carbon neutrality project that has allowed us to work along California's EPA in order to try to see what are the pathways for decarbonization until 2045. And we have engaged with both the policy, with the policy people in the Cal EPA, but also with environmental justice advocacy groups. We have heard some of their concerns about some of the assumptions that we have taken, and we have had some workshops where they give us feedback about some of our work, which is very important in order to try to achieve equitable energy transitions. Moreover, I have had work with Mexican stakeholders, particularly with CONACYT, which is the Mexican Research Council, and INEC, in order to work in this effort, trying to see perspectives regarding the emissions trading system in Mexico. Finally, I'm going to go to my last project, which is Transport Mode Choice and Income in Mexico City, which is joint work with Paulina Oliva and Christopher Sever. In this work, I am going to try to examine within the research agenda that I am interested in pursuing is what are some of the challenges of energy transitions. And again, I am going to be using causal inference methods as well as administrative data and geographic information systems. The motivation here is that transportation sector produces around 28% of global greenhouse gases in the US and 16% of them globally. In this sense, public transportation projects have been considered as a way of reducing global greenhouse gases and pollution. And there are many existing plans to create and expand public transit networks throughout the world. For example, there are some projects in East Asia and Latin America, in Lima, Bogota, Dhaka, and Lahore. The question in this project is whether public transportation projects can meet the growing demand for mobility in middle-income countries, while also trying to account for one common trend, which is that as income increases, also the number of motor vehicles increases in all of these countries. This means that if we expect these incomes to increase in these developing countries, we can also expect that people can adopt private cars, which could in fact increase the total emissions and other pollution problems. So in this project, we are going to try to understand what are the effects of public transit interventions on transport mode. In particular, we are going to analyze how do these effects vary by type of intervention and whether these projects affect income groups differently. There's, of course, a lot of literature in the topic, as well as some people in ASU working in these topics. So we are not the first ones trying to explore this. And in this sense, we are going to be using Mexico City as a case study. And we are going to use it because it has had a rapid population growth, but it also has the second largest subway in the Western Hemisphere and growing automobile use. Also, there are severe problems of congestion and pollution associated with this use of transportation. There also have been a lot of interventions in order to try to reduce the use of private vehicles. In particular, there have been a lot of investment in subway and bus rapid transit lines since 1994. So this is the city setting. This is Mexico City, and here are some of the interventions that have happened after 1994. Some of them are from Metro, some of them are bus rapid transit, which means there are buses in dedicated streets trying to go around Mexico City. And what we are going to do in this project is to first try to collect historical maps and restricted access data for all transit interventions in Mexico City since 1985. This involved collecting maps and manually geographic referencing them in order to associate transit interventions to neighborhood access. Then we use machine learning algorithms in order to predict income, because sometimes we don't see the income where people are living. So we have to predict it using other variables using machine learning. And finally, we analyze differences in transit adoption by distance and also by income. Our main results are the following. Metro interventions increase dramatically the use of transit by about 17.5%. So they increase a lot, given that there is like nearly 500,000 users around Mexico City for just some of these lines. It is a big increase. They also decrease the use of private vehicles. And the same way, the bus rapid transit interventions increase transit use and decrease private vehicle use. Now, what do we find in terms of income? We find that the poorest populations are the ones that are benefiting the most out of these interventions. So the probability of using transit is higher for people that are of lower income than people that are from higher income. However, we also find that as income increases, also private vehicle increases, meaning that places that experience a higher rapid growth of income could have some problems while implementing these interventions if people stay away from using transit into using their private vehicles. With this in mind, our main takeaways is that, again, the design of energy policies are important for achieving energy transitions, but also that the infrastructure for energy transitions might benefit income groups differently. And in terms of the next steps, we're planning to see whether transit adoption changes as income rises and how to implement transportation policies such that benefits populations across the income spectrum. In terms of my future agenda, I am really looking forward to collaborating with people in order to try to keep investigating the main research questions that I'm interested in, also using the methods that I have used before, but also trying to incorporate other methods that I can learn from all the people that I have talked, such as qualitative methods and other methods that could help improve my work and my understanding of these social issues. In terms of my teaching interests, I am interested in teaching some energy and environmental economics courses, as well as quantitative empirical methods. And my objective as a teacher is to provide students with the tools to first understand the challenges of energy transitions, but also identify policy alternatives that can achieve energy transitions with equity, making aware of the inequality existing around the world and how energy transitions can help us close those gaps. In terms of my teaching philosophy, I am trying to explore teaching methods that help students from all backgrounds adapt to meet challenges, in particular trying to advance diversity and inclusion in my classes. And given that we're talking about diversity, I am interested in advancing diversity, equity, and inclusion through my research, teaching, and service. With regards to my research, I am interested in collaborating with minority scholars and students coming from disadvantaged areas and disadvantaged populations in their research projects, as well as making research accessible to diverse audiences. As part of the California project that I talked to you about, I translated all of our materials to Spanish in order to make it accessible for people in these communities to understand our research. With regards to my teaching, I am interested in participating in the recruitment of minority students interested in sustainability, as well as supporting international first generation and transfer students in my classes, given that I know and I have experienced that these students sometimes are shy trying to ask for help while trying to learn in classes. And I am also committing to elevating the voices of minority scholars in my teaching materials. Finally, in terms of service, I am interested in working in mentoring programs for underrepresented students, and I am also looking forward to supporting student-led initiatives to increase diversity. I have had some experience at UCSB being a founding member of our group that tries to increase awareness on diversity issues and as well increasing equality and inclusion in economics. And as conclusion, energy transitions are happening around the world and different paths can have different equity outcomes. My research contributes to guide these equitable energy transitions, and I am really looking forward to collaborating with ASU, trying to make these energy transitions equitable and also advancing diversity in the university. Thank you.
Thank you so much, Danae. What a great set of projects. So really appreciate you taking us through them here this morning and giving us a really, I think, nice glimpse into the kinds of problems that you're interested in and the kinds of approaches that you have taken to grappling with those. I'm going to ask folks to raise their hand in the participant window to ask questions. And while people are thinking about that, I'm going to take the opportunity to ask you the first one. As you know, I'm sure, the Biden administration and Congress at the moment are in the midst of writing legislation designed to accelerate decarbonization in the United States. But at the same time, to bring diversity and equity and justice into that policy framework in a big way. And I guess I'm just wondering, from your research, what would you say are the two big lessons that they should draw for that? Could I ask people to please mute their mics? What are the two big lessons that U.S. energy policy, decarbonization policy should take from your work, and how do they can you give us a little bit of specificity about how they might be incorporated into those bills that are being developed at the moment?
Yeah, so this is a great question. I think that two of the main lessons that I think that is important going forward in order to achieve decarbonization are the following. First, we need to be aware of the possible sources of environmental injustice, and doing so requires knowing where the polluting facilities are and how the polluting facilities could affect disadvantaged communities. And this can take many forms. It can take forms of pollution, but it can also take forms of the possible sources of other possible sources of environmental inequality, such as energy poverty, if they are going to increase the energy prices, as well as other sources of inequality that could happen. So I think that's the first key observation. And through my research, we have found that doing a full analysis and trying to characterize the pollution exposure using these tools, these geographic tools, can allow us to really understand who is being affected by pollution and who could benefit from these improvements. And I think that the second lesson, and I think this is a very important one, is that we need to give disadvantaged communities and environmental justice groups a seat at the table in these decisions as well. I think that when we started this project, we were looking at the world as economists and trying to think these problems from our perspectives. And I think it is very important to elevate the voices of these scholars that have told us this over time and that now deserve a seat in the table making these decisions on how do they think that these policies will work in practice. And I think that that's the second lesson that I have learned through my research as well. Sorry, I think.
Thank you. I have questions from Kirk and then from Netra. So Kirk, go ahead.
Danae, thank you very much. The research is really interesting and covering a really wide span of topics. The question I have for you is going back to the sugarcane story.
Yes.
One of the things that I think often gets overlooked when we say, well, we just need to change this regulation that's going to lead to decarbonization if we just figure out alternate modes of technology, right? And thinking about the human dimensions of those decisions more broadly, like labor justice issues, right? If you say, well, suddenly we're just not going to burn the fields anymore and we're just going to shift to automation. There's other forms of justice that pertain to massive layoffs in those communities, and have you had any chance to really think about the trade-offs around distributional pollution versus a more intersectional lens of justice?
No, this is one very interesting point. So as I showed in this project, when you regulate these facilities and they move away to using more fuel burning, they also increase the number of people that are being employed. And that is a fact. So that could be, this could be beneficial from the point of view of trying to generate employment. However, what I do not find in my research, and this is a little bit more in the weeds, I do not find any change in wages. I only find that people are working more. I do not find any change in wages. So this also brings on to the discussion of a full, more general analysis on whether people are better off or not. And I think that part of trying to analyze the full set of welfare effects of these policies is also analyzing possible health outcomes. So that is something that I am interested in trying to characterize, because you could see that there is an increase in the number of people employed, but not an increase in wages, and possible an increase in health problems. So it is not clear what is the main analysis. So at the end, there are many trade-offs as well. However, many of these facilities have tried to, some of the facilities that use mechanical code have tried to teach these manual workers how to use this mechanical work and try to bring them into trying to use these more sustainable ways of cutting. So I think that's another path forward, is to try to, if these regulations can have a negative effect in employment, to try to change those employments to other sources in the production chain, such that it can improve also employment in these areas. But thank you, this is a great question.
Thank you.
Netra.
Danae, Thank you so much. It's such a interesting setup story embedded in a very carefully designed research. I really appreciated that you enlightened us in a lot of different ways. Towards the end of your talk, you talked about teaching and so on, and that there is where my question comes from. So I'll put you in a situation like imagine that you are designing an undergraduate class around energy transition, let's put it that way there. And the class is very much mixed. That means representing Arizona's demographic conditions, about 50% Caucasians, over 30% Hispanic, and the 20% comes with the Native, Black, Asians, and so on. So it's just kind of that's the demographic that we have, more or less. So through your class, if you have to narrate the story of environmental injustice, especially with reference to the people of color in the US, where do you begin historically?
Yeah.
And how do you enlighten these young learners so that they are not complacent to this injustice and go their everyday life? They just, yeah, Danae's class was very interesting, but I'm happy where I am. Okay. Rather than that, they just start to become an advocate to eradicate this energy injustice, while speaking also to give the opportunity for energy services and so on to this community. So I really like to hear, because we are a teacher at the end of the day, too,
yes.
right?
Yeah, no, this is a great point. I think that the focus that I will give to this class is more about the methods. I know that there's many people here working in trying to understand the wider social tissue and qualitative aspects of environmental injustice. So for me, I think I would try to teach the trends on health outcomes and pollution exposure, as well as energy poverty that have existed since, the beginning of the US, but it has been more recognized in these latest years. So I would start showing them some of these trends historically and try them to let them use both quantitative methods and software that would allow them to calculate the historic pollution exposure gap between disadvantaged communities and also communities of color since the beginning of the since 1900s that we have some data, but more recently using satellite data since 1970s and so forth. So that is how I would approach those classes, telling them that this trend is coming since the beginning of the US, and this will keep coming unless that we do several changes to the actual status quo. I think that I will also emphasize around 1980s with many communities of color went out the street trying to claim for the rights of having clean air as well, especially, for example, in North Carolina, that has been some of the leaders of this energy environmental justice movement. So I think that I will also go through there. But also in order to characterize other inequalities that have happened, I think that it's important to place ourselves in the context of the university and all of the immigrants that come to Arizona and all of the native populations that have also experienced their own set of problems, such as being located, their communities being located to facilities that are polluting, but also regarding waste, as Jen's research has shown. So I think that it's also important to show them the own problems that these diverse groups have faced as well. So I think that for a group of diverse students, I think environmental justice, knowing all of these trends is very important to make them aware and also to make them excited to try to change these existing trends. And of course, I want to do it from a quantitative perspective, trying to teach them how to use satellite tools and how to use them machine learning and also other scientific tools in order to try to show those graphically.
Thank you, Gina. Thank you.
Catherine.
Great, thank you. That was all very interesting. It was great to hear how you're using these more quantitative methodologies to look at these topics. My question is relating more to how do you describe some of your impacts? I believe when you're talking about the sugarcane, you described these as changes in fuel use as some unintended consequences of the policy.
Yes.
And I'm curious if you've actually looked at these policies, and in some cases, there have been policies where changes and impacts like this have been intended. So I'm curious where kind of the looking at the policy and the intended and unintended policy impacts before they're actually happening, has that fit into any of the projects you talked about, or how do you see that fitting into your future work?
Thank you so much for that question. When I started this project, I started trying to look at the health outcomes of rural communities due to sugarcane burning. And then I realized that there was an increase in asthma cases after 2014 and 15 for some areas. So then I tried to go deeper and try to see what was that happening. And I learned later that there was this policy happening that some people believe that it increased pollution due to burning, and some people did not. And at the end, it was a well-intended policy that was targeting overall all of the industries in Mexico. So the unintended part comes from not knowing how these individual sectors might be substituting. So that is how that's why I have framed it as unintended, because when later on I talked to some of the people in the agricultural department in Mexico, they were like, we were not aware of that at all. But I understand that sometimes, especially looking at disadvantaged populations, some of the policies could be intended because sometimes they do not have a saying in these policies and where they are occurring. So I think that in order to analyze ex ante whether a policy can have unintended consequences or not, it's important to know the characteristics of this policy, where the energy policies are targeting, where the energy transition can come, and whether there's substitution across the production process that could cause these unintended consequences, and try to regulate them in order to not be intended at the end.
Great, thank you.
Thanks, Danae. I think one of the things that we have worked a lot on, for example, here, that's worth just interpolating into your story is that, you know, your regulators were like, well, we had no idea that was going to happen. But when you work on knowledge problems like we do, you sometimes realize that that those kinds of lacuna in people's knowledge are not necessarily accidents, not because they're deliberately seeking to make bad outcomes for people, but because the way that we structure our knowledge systems, the way that our disciplines function to focus people's minds, we often find that ignorance is not an accident, and that therefore it's caused us at least to pay attention, as Catherine was suggesting, to this question of intention and unintention, and to be a little more careful with letting people off the hook. And by calling these things unintended consequences. So I have a question from Brian.
Hi, Danae. Thank you. I really enjoyed hearing about all your research. One thing I was curious about, kind of going back to your study of the emissions policy in California, is you find this kind of trend of increasing environmental injustice prior to the policy. And I was curious if you could speak about whether you have any sense of what was driving that, you know, why was that trend there? And then maybe a related question, kind of following up on the previous question, are there any features of the California cap and trade policy that were specifically designed to try to address kind of environmental justice concerns and reallocate pollution in a particular way? Or was it pretty unconstrained and the result you're finding is just kind of the result of, you know, unfettered trading?
Yes, this is a great set of questions. So first, the first question regarding why was there an increase? That we have several explanations. Some of them we are also trying to look for them a little bit closer. One of them is that it was after our period during this before cap and trade was a recovery a little bit from the recession. So there was an increase in production. But another theory that we have, and I think this is very consistent with what other research has found, is that there was a closure of San Onofre, one of the nuclear plants in California, and that generated a lot of, generated other types of pollution from production of other facilities. So that is another theory that we have, and that's based on some of the current research by Lucas Davis at Berkeley and Kat Hausman, who have found that there was an increase on both the imports of dirty conventional fuels and also an increase in dirtier electricity in California. So those are explanations. However, we are currently trying to disentangle this more. This is important also to mention that our prediction of pollution is coming from a first stage that is looking at the difference between emissions. And we do see parallel trends before that happens. So this is coming from this is more about the research design, but it's important to mention to put in context our findings. And regarding the second point, so what we think that part of our analysis, and I didn't have time to go over this, but we did some heterogeneity analysis trying to look at baseline production of emissions before the policy happened. And we see that the most polluting intensive facilities in terms of CO2 were the ones that decrease pollution more. This means that the reduction of emissions is coming from the most polluting facilities. And if we do a correlation on where the most disadvantaged communities are located, is near these most polluting facilities. So if we experience them having a decrease in emissions coming from cap and trade, there is a mechanic there directly. So that is why we think that is not completely accidental, but rather it has to do with the current characteristics of where polluters are and where disadvantaged communities are located. But also California had some environmental justice initiatives embedded within AB 32, which was the Senate Bill 535, which had to do with using part of the revenue coming from the auctions of cap and trade in order to give these communities air quality improvements. So that is one thing that it was embedded within the design of the policy. Many of these communities do not believe that this make a lot of difference. And on trying to solve this, California is currently doing other policies trying to address more micro pollution in a more finite way. So trying to look at a monitoring of pollution exposure near very polluting areas and trying to do community-led initiatives trying to address these issues.
Just goes to show how complicated it is. And I will say, having been part of some of the conversations in the last couple of months about what US decarbonization policy might look like at the national level, there's a lot of oversimplified stories about what works and what doesn't work in California that are propagating in Washington at the moment, and I'm a little bit worried about all of that. Are there other questions from folks? And maybe in the interim, while people are thinking about that, I'll just ask you. We have a lot of students who are interested in and trying to learn how to do interdisciplinary collaboration in their research, and you've clearly done a lot of it. Can you maybe share a little bit of your sort of experiences and maybe lessons from some of that interdisciplinary collaboration?
So one of the things that was really helpful for me during my education was to have one workshop on interdisciplinary research during my classes. This made me work together with people in the Brent School at UCSB, which made me learn how to talk to researchers in other fields. So in this project, we were looking at something completely different. It had more to do with extinction of species, but we had to talk to each other and work together for a full quarter and deliver a paper among 10 people who, I was the only economist. There were some environmental scientists, but there were also people from other disciplines, political scientists as well. So I think that my first approach to interdisciplinary research had to do with this, which was a great opportunity for me to learn how to first communicate and how to translate methods, because some things that we call it like this, some people also use it, but call it differently. So trying to make cross those bridges was very important. I think that by allowing these collaborations from the beginning, so trying to allow students to do this type of projects since the first or second semesters of the PhD is very important for doing so. And I think that that's one of the best lessons that I got from working in interdisciplinary environment. And then the second one is to also know your limits. So I knew that when I was trying to learn how to use an atmospheric transport model, I was not going to learn it by myself. That will be very hard. So knowing when to reach out and how to try to talk to people who are actual experts on your matters is also important.
Glock, I have a question. I can't find my raised hand.
Oh, no worries, Nalini. Go right ahead.
Thank you, Danae. Thank you so much for a very wonderful talk. My question is about outreach and how you make your work available to communities other than researchers. And you talked about the Spanish translation that you did. Can you talk to us a little bit about how the process that was involved in that, and what has been the result and the outcome, as well as the impact of trying to do this translation in Spanish? And how do you see yourself doing this more or not in the future? Thank you.
Yes, so this is very recently that we just had done this. Our lab has not worked with California a lot, so it had been more about other projects. So this was one of the first California-wide projects. And when we finished, we finished the executive summary, and we were a little bit of now what? And my first concern was that most of the people who are living in those communities and who will be affected by the decarbonization and all of these pathways do not speak English even. So to make it available for me was very important. So what we did was to first, in the first stages of the program of the project, we did one a small summary of our intended research, both in English and Spanish. Got it in social media and also in some of our research website. And then after we finished, I translated all of the executive summary, trying to make it as easy, as readable as possible. And also knowing that even if that both these communities deserve not only to be able to read it, but also to understand it. So trying to make it available was very important. And I look forward to doing so also in the future. I have written some blog posts as well throughout my research to try to translate our findings into simpler terms that communities can access to them. And in fact, one of my sugarcane projects was I also had the opportunity to write a blog post for the agricultural and the economic agencies in Mexico, and also all of it in Spanish to try to make it accessible for these stakeholders.
Thank you.
I have Lauren and then Kaylin, and then if we have time, Netra.
I think Netra was first, actually. I don't know. I kind of got
but
that.
He's already asked a question.
Okay.
I'm gonna go to you.
Okay. All right. Executive decision.
Exactly.
I have, thank you very much for your presentation, Danae. So, okay, I've kind of like a zoom out 10,000 foot view question. Thinking about your work on the cap and trade system in California, I'm wondering what you make of the moral hazard arguments that for deep decarbonization purposes, beginning efforts with a cap and trade system actually crowds out the norms that are necessary to get us to complete decarbonization. What's your take on that view?
I think that what California did was an interesting experiment. It might not be applicable in other contexts. And in fact, we see that there's a lot of push towards a policy of more emissions standards and trying to do more technology adoption as well. I think that I don't see these policies as fighting, but as complements, in the sense that they could serve different purposes. Some of them can be implemented in places where it's easier to know the type of technologies that are being used, or that they are more, there's a more uniform technology. Some of them can work in places that have more existing experience in cap and trade and other initiatives, but I don't see them as fighting, rather as trying to tackle different problems for different industries, and as complements of a whole set of pathways that can lead us to decarbonization.
Thank you.
Kaylin.
Great, thanks. So thank you, Lauren. My question stems, I think, right from yours as well. So I was wondering if you would talk a little bit about taxes and maybe some other approaches that you might have thought about. So your talk was very focused on market based approaches. And, you know, when you think of these other options, you talked a little bit about a potential suite of options. So maybe you could talk about some that maybe rise to the top, or some of the considerations that you would raise when you're thinking about environmental justice outcomes.
Yes, this is a great question about more specific how to use markets. I think that some places that have, depending, as we know, some places that may have more uncertainty or there's certain costs, might be better to have this type of taxes, because it's easier to achieve the reduction, and it's easier for these producers to be aware of the cost of the policy. And in fact, in California, it is a carbon market, but it's also the carbon price has been at the floor for a long time. So it has also worked a little bit as a carbon tax as well. So I think that these policies can have different different consequences, and I think that the tax versus a market, it's an important discussion for the type of sector that we will be examining. I think that for places that maybe there is more uncertainty about reaching a certain goal, it's better to use a carbon market. That being said, many of the initiatives that have also had some environmental justice concerns have been related to taxes directly, such as Washington State. So all of them can have different distributional consequences. And I think that it's important to analyze them separately, because they can give us different lessons depending on how they are both implemented and also passed through the different consumers as well.
Thanks. That's, yeah, yes, really interesting comments.
Thank you, Kate.
I want to just take a moment to do a quick follow-up on that, because if you think about energy and environmental policy, we have buckets, right? So we have a market set of buckets, we have a kind of tax set of buckets, we have a procurement set of buckets, we have a regulatory set of buckets, and then we have a voluntary programs, incentives kind of bucket. And I'm just wondering from your perspective on trying to address equity
Yes.
Is there a preference about which bucket to start with? That in the sense that it just makes it easier to make sure that the equity issues are front and center in the conversation, or is the problem ubiquitous across all of these different approaches and tools that the policy sector uses? And then Netra.
Yes. So from the economist, if I get my economist hat for a second, what I will tell you will be that for each problem that you want to tackle, you want one policy that tries to address that problem. So if you want to regulate greenhouse gases, it's better to use a policy tackle to that. And if you want to use an environmental policy that tries to address environmental justice, a policy should be used for that. I think that in practice, we need some sort of in-between where there are some policies that could help us achieve both to try to tackle them directly. And I think that depending on the context, these policies can look differently. Sometimes emissions standards or more of technology standard could be helpful when it's easier to adopt these technologies rapidly, and it doesn't require in a very high cost for these consumers. And we know the possible effects for disadvantaged communities. But sometimes taxes or market policies could be helpful in situations where we want more flexibility and less cost from part of these regulators to try to achieve their environmental targets. All that being said, I think that if an environmental justice outcome should also be like directly stated within that, because in order to better solve the problems, we need to tackle them with instruments directly.
Thanks. Netra, go ahead. Sorry to have put you off there for a few.
No, that's how the justice works anyway, so don't worry. Danae,
Yes.
this is not so much a scholarship question,
Yes.
but it is a question about you and who you are as a scholar. And let me preface by saying that, some of us choose a particular field because of some passion to that. Some of us land accidentally in certain areas too. I have to be frank. And the more I read about you and hear about you, I'm very impressed. And I put you as a sort of emerging development economics scholar with the insight and policies and the injustice in society and so on. So if you don't mind sharing what inspired you to go into the field of economics that is largely dominated by white man mostly, and so on. So I would really want to hear that, because again, if you don't want to share, please don't. But I'm very much inspired by your work and so on.
Thank you so much. Thank you so much. I really appreciate it. I think that I had mentioned this to some people yesterday, but when I decided to be an economist, because I am from a very small town in Mexico, very close to rural areas. And I went to school with people from these rural areas, and we visited them constantly. I am very familiar with all of them. And for me, it was very unfair, and I wanted to eradicate poverty. At the same time, I really liked math. So I said, well, I want to finish poverty, but I am also good at math. So let's just do economics. It just makes sense. And then when I later on, it just realized that for me, it was the right decision. And I saw in environmental economics a way of knowing that people in rural areas depend so much in the environment. But people in urban areas also depend so much in the environment for their well-being and for their in terms of the quality of the air that they breathe and everything. So I realized that something that was embedded in all of this and in the poverty that I wanted to eradicate was the environment. So I decided to try to look for environmental economics, and the justice part for me was very important. And I think that after all of what we've seen the last year has just made me more more eager to try to tackle these issues, because I don't think that we can solve many problems in terms of inequality until we solve environmental justice.
Great, thank you.
Sort of a follow-up question to that, Danae. So throughout the talk, it's always a problematic thing, right, to talk about equality versus equity. And so we can really trace the inequalities that are resulting from any type of policy or regulatory practice. But this question of the way that equity can be achieved without exacerbating inequities. And I always think about this with decommissioning nuclear power plants, right? They're obdurate infrastructure, they're reaching their end, but you can't make it more equitable just rebuilding San Onofre, right? That's not actually going to address the problems that we're trying to address. So can you just riff a little bit, muse a little bit on how you see the difference between what you study in terms of creating more equitable relationships versus more equal relationships between people, their environments, and then the administrators who are meant to protect both?
Yes. This is a very good question, and sometimes I ask this a lot myself. What is what we're trying to achieve and how we can achieve it? And I think that I see trying to solve inequality as a way of trying to give them the fair starting point to people, such that then we can say maybe these later outcomes will not be the reason why they are different is not because they had different opportunities. So I think that for me, this inequality, this equity discussion goes in part with trying to give both groups the same opportunity to get the same outcomes in the future. And I think that part of that is embedded in trying to make both try to offer all of communities clean air and trying to let them have the opportunity to move to areas if they don't want to experience that clean air, or trying to not put purposely one power plant next to them because they are a minority community. But also it's part of trying to give them equal access to the decisions made by policymakers. So I think that both of them go hand in hand, and I think that's how I have learned myself, like how I see it. But yeah, this is a great question.
Thank you.
Anyone else? Otherwise, I'm going to ask one last question, but I'm happy for somebody else to step in. All right. Well, seeing no other takers, I'm going to ask a completely unfair question. You've shown us a number of projects and mentioned several more, and I know from talking to you that you have lots of projects that you're working on and pushing forward. And I guess what I'd love to hear is, sort of 5 years from now, 7 years from now, what you would hope to have accomplished intellectually across the portfolio of projects, as well as maybe a little bit with respect to what kind of relationships, collaborations, teams you might like to have built here. And all of that is perfectly fair as a question, but I'm going to tweak it just a hair and make it, I think, probably a little more unfair, which is to put that in the context of the fact that as a country and a world, we really have about 3 decades to get this energy transition done, which means that the work you're doing over the next 5 to 7 years isn't in some ivory tower intellectual context, but rather in the context of a very real problem that encompasses every person on the planet. So I totally understand that that's an unfair question to ask you, but I'm going to ask you to try anyway.
Yes. No, I think I want to position myself as a scholar who's an expert on trying to achieve energy transitions with equity. I think that to do so, it's hard in terms of how we are going to achieve it, but I want to collaborate with people from other disciplines that allow me to answer this question in a more complete way, not only from the economics perspective or using the tools that I use, is trying to know at all of the other issues that go hand in hand with these transitions that are not only economics, that it's only science related, technology adoption, and also social interactions that could be happening that we need to be aware of. So I really look forward to be an energy transitions scholar, more so than an environmental economist in my field. And how do I see my research making an impact is through trying to engage with both community members and policy stakeholders. I have done so in some parts already. I do not have a lot of experience in the community engagement part, but I know that many people at ASU has it. So I am really looking forward to collaborate with people who have, and I know that many organizations within the College of Global Futures have this experience. I am really looking forward to be part of this effort to try to reach out to communities and also stakeholders.
Thank you so much for the discussion today. And I know that the students are really looking forward to meeting with you a little later, as well as a number of our faculty colleagues. So let me say thank you. And in a minute, I'm going to turn it over to Dave for one final message, but give you a chance to say thank you as well.
Yes, thank you so much, everyone. I really enjoyed giving this talk and all of our conversations yesterday. I'm really looking forward to meeting more people. Please email me. I am really looking forward to connect with people if you have any other questions or want to know more about my research. And thank you so much again for this opportunity.